All right, let's run through a VLSM question, and let's imagine a small business called Tech Innovators, which has different departments with varying IP address requirements. They want to set up their internal network using the private IP address block 192.168.1.0-24, and the IT manager has provided us with the following requirements for the subnets based on the number of devices in each department. So we have 4 departments here, each with different requirements. We have the HR department that requires 50 hosts, the IT department that requires 30, the sales department that requires 10, and then the research and development department that requires 5. So we have 2 tasks in order to solve this problem. 1, we have to subnet the given IP address block to accommodate the required minimum host for each subnet using VLSM. The keyword here is minimum, so we don't want to use a block that provides way too many addresses, so just the minimum amount. And then second, we want to provide the subnet mask the range of usable IP addresses, the broadcast address, and the network address. And we're going to be working out of our Excel spreadsheet here. So the way that I would tackle this problem first is by focusing on the department that has the largest amount of hosts. So in this case, we have the HR department. It has 50 hosts, and so this would be our starting point here, our reference, and then the second step would be to work here. So basically, when you're doing a variable length subnetting problem, what it all boils down to is borrowing host bits. So in this problem scenario, we were given the -24. So since we were given the address block with -24, we're going to be working within a specific range. This is the range that we're going to be working specifically in. So any number that we input here on the CIDR column is going to be either 25, 26, 27, 28, 29, 30, 31. It is not going to be any of these numbers. These will essentially cancel out. We're only working within this range, 25 to 31. So when we're borrowing host bits, essentially what it's going to look like under the hood is this. So here we have the -24, and we have it as a subnet mask. We also have the binary conversion. And in octet, so these are an octet. So this is 1 octet, another octet. An octet basically starts after the dot. So here we have 4 octets in total. And so we have the -24, which basically means that there are 24 bits that signify or represent the network portion. And then the rest, the zeros, represent the host portion, which is underlined in blue. When we're borrowing host bits, it'll look like this to a computer. When we borrow that host bit, we're basically redefining the network portion of that address. So this 1 becomes part of the network address, and the rest are hosts. So since we borrowed that 1, a few things change. It's no longer -24, it's -25. And here you'll see here that there's a base 2 binary chart. So this represents the last octet. So to reflect the changes we made, it would look like that. And then so this also changes, and it changes to 128. So now to calculate the amount of usable addresses, we take this number, 32, and we subtract it to 25. Then we do 2 to the power of 7, which gives us 128. So this 128 basically means that we have 128 addresses in this range. Now, this is too big of a number to specify for the department. So as you can see here from this problem, remember when it said minimum hosts? 128 would be way too big of an address space to assign to the HR department. So we're going to go ahead and borrow another host bit. And so we're going to do that. Again, we're redefining the network address. Then when we're borrowing that another host bit, two things change. The CIDR and the subnet mask. So how do we get the subnet mask for -26? Well, we change this to a 1 because we're reflecting the last octet in the IPv4 address. And then we take 128 and add 64, which is 192. And this would fit the minimum requirements for the HR department. Do 26 255.255.255.192. The range will start at 192.168.1. Okay, and then to find the broadcast address, we have to take 255 and subtract it by 192, which gives us 63. So the 63 will represent the broadcast address, 192.168.1.63. And then the network address will be 192.168.1.0. The last host is going to be 1 minus the broadcast address, so 192.168.162. Okay, so now that we've solved for the department that requires the most hosts, we could basically just do the rest pretty fast. So the way that I do that is since this is -26, I'll do -27 for this, -28 for this department, and then -29. And then since this is the broadcast address, the next block's network address is going to be +1 of the previous broadcast address. So it's going to be 192.168.164. So as you can see, this is subtracting 1, the broadcast address to the last host. Then for the next address space, it's .64, which means the first host is going to be 192.168.1.65. Okay, so once I filled in that CIDR column, now I can basically work with this using this calculation. So 32 minus 27, because we're on the IT department now. We're going to do that. 32 minus 7 is 5, so 2 to the 5th power is 32. And we're going to subtract 2 because we're reserving the network address and the IP address. And then it's going to be 65 plus 30, which is going to be 95. So 192.168.1.95 dash 192.168.94. Okay, the next network address is going to be after this broadcast address, the previous broadcast address. So we're going to start it with 192.168.1.1.96. Okay, which means the first host will be 192.168.1.97. Okay, and then 32 minus 28, 2 to the 4th power is 16, minus 2 because we're reserving the network address and the broadcast address. We take that 14 and we add it to the first host. So 97 plus 14 is 1111. 192.168. So that means that's 110. And then so the next network address is going to be 192.168.1.112. And then take, so that means this would be the first host. So 113 plus 6 is 119. So 192.168.119, and then 192.168.118. And then for the subnet mask, 192 plus, so we have 128 plus 64 plus 32, so that's 224. Plus 16, 240, and then plus 8 is 248. So then it would be 255.255.255, and then 255.255.255. And then that's how you would solve for the variable length problem.